Hello, everyone, and welcome back to our second last session for you. This one is on energy, and then our very last one will be just the one that is specially kept back for the grade 4, 5, 6 groups, and that is for space. My name is Chris Arski. I'm one of the designers of professional learning. Wow, I remembered it this time. DPLs are calling us. And I have the distinct pleasure of working with the best partner in the world, and I'll let Ted introduce himself.
Thanks, Chris. Hi, everyone. I am also a designer of professional learning. I'm working through the Edmonton Regional Learning Consortia, and welcome here this evening as we unpack grade 4 energy.
Yes, and we are, I guess I want to preface right up front, we would have been happy if it had gone a little deeper, but that's okay. We're going to touch on as much of it here as we can today. And we also are going to just share with you as many sort of strategies and ideas that we can give you as a suggestion. Remember that nothing in the videos is meant to be in order or necessarily that you do everything. These are just hopefully there to either help prompt thinking of things that would fit well with the unit the way you saw it and wanted to plan it, or that you just get some ideas and can use snippets from here and there or whatever. So just a reminder that they're just suggestive in nature, that they're not certainly mandatory in any way, shape, or form. So we are going to begin with our land acknowledgement, but before I go through that land acknowledgement, just want to share with you, we always try and put something on the in this acknowledgement that kind of links to what it is that we're working on and what we're going to be presenting to you. Just an FYI, tomorrow we're going to include Aurora Borealis into this conversation. You'd see the links, but if you're looking for another idea as well, maybe check on the grade 5 link tomorrow. So this time we've included the 7 sacred teachings, the grandfather's teachings, and they really tie very well into the energy, the spiritual world, the beliefs, but also in that story will include the 7 sacred animals and the meanings of them. So it's a beautiful tie. If you've never actually read the 7 grandfather teachings or heard them, this is read to you by Etienne Moustus-Lafferty, and she does a beautiful job of it. And it's a great way for the students to hear it. And you can integrate that into language arts. You can integrate that into health. I mean, this is not just about the connections with science. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So we are going to have a little bit of a peek to see how energy was unpacked through K-3. And to give you that spiral, remember that spiral approach, that everything is building on one grade to another. So it'll be really important for you to know as grade 4 teachers, what is it that students in a perfect world, had everything been done, would arrive at your doorstep with, okay? And if it was next year, you would know what they've covered in grade 3, but would have been missing pieces that the grade 3s had to look at as well from K to K1, 2. So we'll talk about that. We'll do an overview of the grade 4, and then we'll talk about what are some components and some strategies that you might use, some activities, some resources, and hopefully that will give you a good start. So I'm going to turn it over to Ted, and he's going to start us off with the big picture, and then we'll start in later with some resources.
Thanks, Chris. Once again, those of you who are with us maybe for the first time here, I just want to do a quick review of where we've been and where we're going. And this graphic here that we have in front of us is just a little story of where we've been. Those images you see at the top, those 5 black things are intended to be silos. They're images of grain silos. And you can see they stand alone and representative of, I think, of the way the topics and the unit system in the old curriculum of science was built. So at grade 4, we know we spent some time building devices and vehicles, and then we moved to light and shadows. And we moved to plant and growth changes and so on. And if there were connections made between those topics in your science classes, is probably very purposely done and probably took a little bit of thought and pre-planning to do that. And we'll see right away here that the current curriculum now helps make that switch and that connection from one sort of organizing idea to the other, or units, if we were to teach these organizing idea in units. So there's something in the structure and the way this new curriculum is built that allows for ideas and information and things to transfer from one organizing idea to the other, unlike those topic silos that were just individual standalones. So I just want to do a quick review of what makes it possible for the interaction to happen between these organizing ideas within each grade. And as we'll see, not only within each grade, but between the grade or between the other grades as well. So one of the things that we know that makes that fluidity, that spiraling curriculum that Chris mentioned earlier, is the idea of concepts. And just as a quick graphic, I'm going to show you how the sort of conceptual understanding of energy builds from grades K to 6. We begin kindergarten kindergarten energy with a look at movement and how what movement is in terms of change and change in location and position. And then we explore movement through objects and animals. By the time we get to grade 1, we see that we look at movement a little more deeper, not just the way things move, but we could see in the right-hand bottom, objects move with a direction, the pathway, and a speed as well, and then the influencers. By the time we get to grade 2, we take a look at movement not only and specifically with sound and light, and what that movement behavior is like, and what sources of light and sound are. Grade 3, we move on to the notion of force. That movement happens because of certain forces acting on things, and we'll take a look at the contact forces in grade 3. By the time we get to grade 4 now, we could see that we continue to build that whole notion of force, and we're talking about the non-contact forces. And there should be a line from forces, I'll fix it up, from forces down to the light blue non-contact force, because they also have a strength. And we focus on magnets and gravity in grade 4 in terms of non-contact forces. Grade 5 takes a look at how flight actually is affected by the different forces. So we look at things like not only gravity, but other forces such as drag, thrust, lift, and buoyancy. And finally, grade 6, we add a little bit to the top part, and we take a look at forces such as the contact and the non-contact forces as being external forces, but there are also some internal forces at play that affect objects and materials, and that we know that a lot of the effect is on the properties of things. And we can change things because they sometimes have that plasticity and elasticity to them, which affects their shape as one of the properties. So that's generally how the energy organizing idea unfolds. And once again, you can see lots of connections between them along the way. And we could probably see, if you recall the other organizing ideas, we can see things like property and objects come from matter as well, and even change and movement also appears in other organizing ideas. So lots of connections between them. Specifically for grade 4, what we're looking at in terms of the ideas here, we're looking at force as a non-contact force that acts on, if we look to the left, objects, materials, and substances. You know that forces have a strength that does change with distance. When it comes to a non-contact force, the two key forces we're looking at here are gravity and, almost more specifically, the magnetic force. We do explore gravity a bit, but the emphasis is on, as you can see, magnetic forces. And we learn about magnets with their poles and how they interact with each other and attract and repel each other, and how that all works together. So this is what we'll be unpacking in this presentation with the organizing idea of energy. Just as another graphic, besides the concept map that I just showed you, that progression from K to 6, we have another progression that's more a linear word-based one. You've seen this before, and it's available. It will be available through the link at the bottom on this slide when you get this slide deck. We have one of these progressions for each of the organizing ideas from K to 6. This one shows energy. And what it's helpful to do is to take a look, what it's helpful for is to take a look forward or behind and see what concepts and main ideas were covered before the grade that you're working with, in this particular case, grade 4, and what's needed to help understand and help students be successful in grade 5 in the following grade. So this is available to you if you want to take a look at that. It is helpful to look forward and back to see where grade 4 sits in that whole spirally nature of the curriculum. Besides the concepts, we know that there are skills and procedures that do flow in between those silos that makes those connections as well. You'll notice at the bottom I've highlighted computer science and scientific methods, and that's because especially in this organizing idea, we'll see a lot of those skills and procedures that were introduced in those organizing ideas reappear in the content portion of energy. So knowing what some of those are will really help us unpack and help students to deepen their understanding of the energy ideas by using some of those computer science and scientific method skills. And we'll see examples of that as we move forward through this session. So the key verbs here for this one, and it's been the same for K to 3 as well, and especially now grade 4 again. The key word in the verb in the learner outcome is investigate. Once again, those verbs are there. That's what students do to demonstrate their knowledge and understanding. So in the learner outcome for this organizing idea, students investigate how forces can act on objects without contact. Investigate, as we'll see, has a series of steps to it, and we'll go through those a little later on in the presentation as well. Specifically, there are the 2 understandings, and again, the skills and procedures statements associated with those understandings. We're talking about describing, conducting investigation, analyzing, and when we're talking about describing, we're really using that whole investigation procedure. We're explaining how things happen based on our investigations. If we can demonstrate something, we're doing a little mini explanation there. If we're conducting a full-fledged investigation, we're beginning by asking a question and going through the whole process of making predictions and observations and maybe demonstrating, and then drawing conclusions based on the data that we analyzed from our experiment or investigation. And analyze, if you look further down again, is one of those key skills involved in that whole investigation process. So those verbs that we see there flow in and out. We've seen them in grade 3, we've seen them in grade 2 and grade 1 as well. And that's so another thing that we keep coming across as we go through the science organizing ideas. So if these things do move around from one bin to the other, one silo to the other, and they move around from grade to grade, in a sense, these concepts and skills and procedures, we're transferring. We're giving students new contexts, new situations to practice their skills and to demonstrate their understanding of these concepts. And so we're going to do that quick review of what that really means. And the next slide is, again, a graphic that you've seen before. And it's there to emphasize that those individual skills and concepts, we begin teaching those at a surface level. If there are new concepts such as force, we help them understand that at the surface level, and we deepen that all the way and give them experiences so they can eventually transfer to the new context. Same with the skills such as investigating or analyzing. If it's new to your students who want practice at the surface level, give them many instances and opportunities to practice that skill so they become more adept at it and more independent with it, which means we're starting to get them to transfer those things. So we want to give them different investigations and different questions to work with so they can practice that investigation procedure in different ways. Same with the understanding. That's the concepts that are connected all together. We introduce it and begin having students practice applying those understandings and seeing those understandings in different contexts. And again, we have them explore that in new contexts we move along. And so it's transfer activities that really essentially become our assessments. We're giving students an opportunity to demonstrate what they know and understand using a context that is new and unfamiliar to them. Similar to the way we unpacked Earth systems, we're also going to unpack the energy organizing idea by beginning with the end in mind, or that backward by design, which really means we take a look at the learner outcome and these understandings, and we begin there and plan our assessment and how we're going to assess those understandings. That'll help us design our learning activities that need to occur at the front end, beginning with the surface and deep. So what we're going to do right now is just share one possible summative assessment. In this assessment that is in the sample below is a way to help students investigate, or a way to have students investigate how forces can act on objects without contact. There's probably going to be many investigations they're going to do, but this may be one that may be a new context for them. With any of these activities that you see, and I think Crystal will again point those out later as we go, that this can be a summative assessment. This can be used as an activity that you use to deepen understanding, if that's what you want. It depends how much independence you want to allow the students to have to be successful in this. But if this is your summative assessment, it might look something like this. You can go ahead and click on it for a second, Chris. Oh boy. Unable to open the document this time. I think I probably have a typo in there, maybe. Can we just pause and I'll just fix that up?
Sure, absolutely.
I probably misspelt template or preview or something. So in this particular assessment, I won't go read it verbatim here, but what really is going to happen is the students are going to be given materials of some magnets and a compass and a sheet of paper. And by using those, and it could be as independent as you want with this, if they've done many investigations, you really want to assess whether they can put together an investigation to determine something. You may want to leave it quite fluid and not very directive in what you have the students do. And it could be assessment to see how familiar they are with the investigation process. They can have the steps there in front of them, but how they conduct an investigation could be totally independent. And they may come up with different ways than what we provide here. But at the end of the day, and the students with this assessment are asking the question, what happens to the attraction strength of a magnetic force when magnets are combined? And so that becomes the question. And then what we have here, students are be given some magnets, and by using one magnet, they'll pull it close to a compass to see how far that magnet is that causes the north to start pointing south towards the magnet. And we record that distance on a sheet of paper. I'll show you that in a second here. Actually, Chris, you could scroll down to the next sheet. There's a picture that would show what there's the magnet. It's you can see that it's actually not pointing north, it's pointing south now. And I've measured that as five centimeters away. And then I pull the magnet aside and I do the same and slowly bring up magnets stuck together with two of them. And I record that distance and so on. And so that's what students will be doing in this investigation. What they'll get is a investigation sheet. Again, if they're still new with investigations, this planning sheet may help them along. There's a recording data sheet. Yeah, that's the one, Chris. Where I've done the same thing. Okay, I'll go back and fix it up, and you can just refresh here.
Okay.
I probably put preview template again and got it all backwards. So I'll go through. Students will go through certain steps as they do this. We begin with the prediction, and there are some sheets of questions there to help with the prediction. We begin with the investigation question, of course, which is given to them in this particular case. And they make a prediction about what's going to happen when you bring more magnets closer to the compass. Is that magnetic strength going to increase or decrease? And so once they make their predictions, then they can start planning or start conducting the experiment itself. And you can scroll down to the next sheet, and there's an observation thing where they can perhaps, if you can give that to them, ideally you'd want them to make their own and show that they know how to do that. But it depends where you are and how much practice students have had with making data collection sheets and so on. But if they're familiar with it, they can create their own. If not, there's one for them. And then we gather the data. We know that in grade 5 computer science, students distinguish between qualitative and quantitative data. And the idea of reliable data is included in here. So one of the things we have them do in this particular assessment is compare what other students have. Is their data reliable? What makes them think so based on what their observations are and comparisons with other students in the experiment. And then we go on after have all the data, we analyze it, and we can give students some questions like, by analyzing the data, I see that. So they have that record. And what does it tell us when we see the distance and sort of the strength of the magnets? What do they notice based on the distance? And then, of course, there's their conclusion. The conclusion can be a conversation. You can ask them to represent it and explain it to you. It could be a written response in the space below. That would be up to you how you may want to assess this part on the conclusion, depending on how well students maybe can communicate in writing. And finally, there's just a couple more parts. After completing the investigation, I have these new questions, because we know that the first step in an investigation is asking questions. In this particular case, the question was provided, but now they have new information and some new things they've figured out after they've analyzed the information that would prompt them, we hope, to ask some new questions in this. So that's what the assessment might look like. And there's a lot there for sure, but that's where we use the learning activities prior to this, and that's what will help plan us. What we do have there is a one other thing is how you may want to assess this at the end of the day. Oh, I got the wrong, it's not hooked up to the template, is it? That's okay. There's a single point rubric that you'll get that's attached to this that will help to help with your assessment. And so now we know what the assessment is going to look like. If we continue with that backward planning, we do ask ourselves, well, what do students need to know and understand to complete this assessment? It's fairly big, it's fairly robust. And what will students need to be able to do as well? And the next slide just shows some things. They would need to know the steps of investigation. They'll need to know how to measure for sure. And the steps of investigation are include making predictions and analyzing. So they'll need to be familiar with that. And they'll need to know such concepts of what is movement, force, the types, direction, magnetic material, attract and repel, and so on. So that's the backwards by design process. We know what our learner outcome is. We have a pretty solid idea what the assessment might look like. Now we decide for pre-assessment, what do our students need to know to be successful in this? And that pre-assessment will help determine what we need to teach. And so there's a lot of pre-knowledge that comes into play here with the energy organizing idea. And Chris is going to take you through some things that students have uncovered from kindergarten all the way up to grade 3.
And so, as kind of was pointed out at the beginning when we started, and you've been hearing all along, that spiraling of the curriculum is really, it is really different from what we've done in the past. So there would be things that in a perfect world, if you were teaching this year, or if you are teaching it this year, that the students will not have arrived at your doorstep with. And so just, again, as I go through this, just give some thought to your kids that are sitting in front of you right now. And if I'm starting to talk about something where you're saying, I'm not really sure actually if they do know that, then you would be able to go and grab some of these slides. We didn't give you the whole slide deck from kindergarten up. We're just giving you the highlight ones that really are the meat of the matter to where you've got to go with them in grade 4. So in kindergarten, they talk about movement, they define movement, they ask them to explain it in their own words. And that's an important start, because that's really what we're trying to do with the magnets and gravity and when that conversation. They unpack sort of the types of movement as well. So they look at it from an up, down, a straight line, a round, a motion. So all the different kinds of things that we can have for movement, which eventually into grade 1 start into pathways. So we define them a little bit more strategically. Instead of just general terms of motion, we say, what is the pathway? Is it an up, down? Is it a zigzag? Is it a forward, backward? What kind of pathway does that object have? So in grade 1, as an extension on that, we also talk about direction, pathway, and speed. So how are those determined, and how are those affected by the amount of force or the amount of the type of movement that I want to do? So of course, friction comes into some of that conversation, but not nearly as deeply as we're going to go or would have gone in previous. So again,
track loves to go forwards.
Sorry, these guys always start as soon as we get going. We also talk about how does the shape of the object influence whether or not it's able to move easily or not so easily. So typically, and this is done purposely, the note says, how does the shape, and it's a cylinder. So clearly if I've got it sitting on its ends or on the circle sides, I've got a flat base, and it should slide fairly simply unless I have a rough surface, and then it might not. Whereas if I turn it on its side, I can roll it. So again, what are the possibilities for movement based on shape? What are the influences that materials have? So if it's a boulder, like this man standing on top of a rock boulder, I can go there and push on it all I want. I'm not going to budge it. So the material itself determines the fact that in this case, I'm not moving it. And if it was all, let's say, made out of foam and it was for a movie, I might be able to move it, but even then it's a pretty big one, even made out of foam. So it might be unbalanced or whatever. But again, we talk about what are the materials that influence and how does material influence? And then the texture of the surface. So is it a smooth surface? Is it a ruffled surface, rough surface, uneven surface? How does that influence and affect motion as well? So as we move into grade 2, we look at, now that we've got sort of an idea of how things can move, we translate that into sound and light. So how does sound move? And that means that I need to have an understanding of materials, because we're going to talk about, let's say, echoes. Can't have an echo unless I have a really firm side or wall or something that my sound is going to bounce off of, as opposed to something that's soft, that's fabric, that absorbs the sound and changes it. So we talk about the characteristics of sound, so volume, pitch, and duration. We talk about what are some sources of sound. So musical instruments is one, because we ask them to design something. And in this case, we even asked them, could they make a musical instrument? And can it make sound and whatever. But just talking, right? Our vocal cords also give us sound, and we can go up and we can go down and we can go loud and we can go quiet. So again, just different sources of sound that students can identify. And then the material characteristics, which would affect what happens with that sound, whether it reverberates off like an echo if I'm in a cave and I've got, let's say, solid walls that are fairly smooth. Think of going into the gym. That's been a fairly common one that we've been using all along here. Go into a gym, children, especially the little ones, they're squealing. They just love it because they hear that bit of an echo that comes in. Their voices get louder because of the bouncing off of the walls. And so it drives us crazy as teachers, but nonetheless, it's something that they're already in tune and they can hear it. They know what happens when they go into the gym. So when it talks about travel of sound, we still talk about pathways. So now that I know about pathways from my previous grade, I can talk about how does the sound travel? What pathway would it take? So if I'm talking about the echo, for example, so the echo, the blue line is going off, it bounces off something solid, hard, smooth is even a better one. And then it comes back as the green dots. And does it do that all the time? No, it doesn't. I can walk into my house and yell and I don't see it coming back, because I've got all these different entrances and different places and different substances and objects that are sitting in the room that are absorbing the sound. So I'm not getting that reverberation that I see back again. So that's what they learn about. Again, there's lots of videos along the way here that if you think we just need a bit of a review, not necessarily a lesson, we're not going to go back and reteach the entire grade, but maybe I just need a little bit of a review through a video to bring them up to speed. And then I guess of the slides that we had in light, this is probably the most important one, because it would offer you all three aspects of what we study in light. So it looks at basically what it is. First of all, how do we define light? What is light? And then what are sources, just like we had for sound. And then we talk about what's a natural source of light versus an artificial source of light. And so again, just that kind of encompasses in a broad stroke all of the components of light that we are going through with the grade 2s. And then as we move into grade 3, we, as you saw on the concept map, we now get into force and we get into contact forces. So in other words, I want to push a baby carriage. I want to go to the store and push a cart down the aisle. And those would be great examples for the students. So they get a sense of what that means by contact forces, and that contact results in something. Either the object moves forward or the object doesn't move, depending on all those other things that we talked about. So we talk about what force is, first examples, and then give them examples of it. We talk about what are some common forces that we have in our daily lives. And one of the activities that we challenge them with right off the bat is, what are some of the forces that you encountered between the time you got out of bed this morning to the time you sat down in your desk at school? So what were some of the forces that you connected with and that were working as you were doing the things that you would do every day? We gave them examples of what forces are. We gave them common examples. Again, this is on a video, so if you feel that that would be something just to help prompt thinking again, because you're going to be talking about non-contact forces. And we do talk about gravity in these conversations. Even though gravity isn't really developed a lot in grade 3, it's pretty hard not to have that brought in at some point to have a bit of a conversation. But it really gets unpacked more with you in grade 4. So the terminology is there, but not necessarily the understanding. So contact forces could be pushing and pulling, could be friction involved, could be tension where I'm pulling, tug of war, that kind of thing, or sort of an elastic or a spring model where you maybe have a jack in the box pop out and it wobbles around and it just shot out because it was compressed down, and when the top flips open, it comes up that way. What are some other examples that the kids can think of? If they have slinkies at home, that's a good one. Again, there's videos here that you could access if need be. Anything that's underlined are already hyperlinked to sources for you. How can we describe pushes and pulls? What kind of push and pull are they seeing in this picture here, where we see a logging truck getting pulled up of a steep hill? And what are some of the forces that are acting on that? That deeper conversation about what forces are acting on this really could be asked again. The same question could be used again, or same picture in grade 4, asking again, what are the forces? What has gravity got to do with it? What role does it play in moving this truck forward or making it more difficult for it to pull the load? Okay. Or what about weak and strong forces? We talk about even just taking them to something they're familiar with. Maybe it's soccer. You've got soccer players in your class, or you've got baseball players in your class, or you've got football players. Like, what is it that they're really into and that they really enjoy? And then again, how does that get reflected in terms of a force? So describe the force that exists within each one of these, the strength of it, the direction of it. So they have to know something now about their forces in order to give you a bit of a description here. So naming what kind of force it is and how it might be influenced by the kind of force that I'm describing, push or pull in this case. And is there any kind of resistance? Is there resistance when we slide over the snow? Is there resistance when you're pushing the cart? Is there any kind of resistance when you're pushing or pulling on a tug of war string? Or what about when you jump out of a plane? You know, why is it that you don't just instantly drop to the ground? There's something holding you up. And that again comes into grade 4, even more so into grade 5, right? So we're just building this very slowly as we go along. So pushes and pulls, normally we give them a Venn diagram that's empty and we say, you know, here's some words and can you put them in? This is kind of a reverse of that, and you could do that. There's nothing stopping you from grabbing 2 hula hoops, putting them down on the floor and giving them the terminology that you see there and see if they put them in pretty much the same places. But in this particular case, we're saying, can you name other objects that could fit into this Venn diagram? Left, right, and middle. So we want them to think beyond what's just sitting there. So just again, it's just a reverse of some of the things that we've been doing in the past. There are some resources that we have been locating that are really actually very good. These ones come from Core Knowledge. And in these particular resources, what you have is an actual book, a teacher's guide, and a student book. And these are PDFs, so you are able to download them. They are freeware, and you are able to use them in your class. Now, you wouldn't necessarily want everything that's in there, but for the most part, you can see in the table of contents, it does skip a little bit in from grade 3 into grade 4 already. But there's a number of things in here that would be definitely something that might help if you're feeling your students are a little bit behind and you want to do a little bit of work with them. Then you have those options to get in there and do that. And that link is at the end of the slide deck. We also talk about simple machines. So what are those simple machines? How do we define them? What is a simple machine, first of all? And that's where this one starts. Just what is it? And then we unpack all of the different aspects of them and look at what are the benefits of using one, where would I use one over the other, etc. So again, this is a slide in which you have lots of videos. If you feel you need to go back, in the middle, we have a question. Look around your classroom, bedroom, home, find some examples of simple machines that exist right around you. Okay? And they might find some in the classroom, they might find them out in the hallway, they might find them at home. So again. So looking at sort of a concept map, Ted's created a number of cards. Could they take, once they've learned their terminology, and this would be a great formative for you. Maybe you give them this, if you're assuming they know it, give them these cards and see how they would put them together in a concept map. See what they would do. That would be a great formative for you to see the kinds of conversations and to listen about the questions that they have. And that might be an indicator for you right there. Anything you want to add, Ted?
No, nothing other than if your students have never worked with concept maps before, you want to make sure you give them some time to practice them. And there are a couple links that'll there on the left-hand side that'll introduce what a concept map is. But more importantly, I think the more important, not the more important one, but one that should precede talking about concept maps. So just talking about what do we mean about relationships? When we ask how two things are related, what does that mean? Because at the end of the day, that's what a concept map does. It shows relationships between ideas.
And so the next slide just gives you a possible solution. And again, the power in this will be in what the kids.
Go ahead, Chris. Yeah, go ahead.
I was going to say, whatever they explain to you, it's not necessarily where they placed it. It's more of, why did you place it there? What's your rationale, right? And then we can unpack any misunderstandings as they're going through, or that they've nailed it, really. I mean, that's really what you're looking for, is do they have a good understanding where I want them to be? Or there's a few things missing there. It was a good explanation, but it wasn't really complete yet. So I need to do a little bit of work just to get them to think a little bit deeper. Anything else, Ted? Okay. So let's go into those non-contact forces. And the first thing I want to start with is in fact one that is contact. You know, we've got lots of kids that you have skateboards at school, and they sometimes bring them to school, or that's what they use to get to school. And in this one, it's just doing an ollie, right? It's just for kids who've got skateboards, that means something to them. And if they're really adventurous and they like to do that kind of stuff, they get what it takes to take their board and flip it up and jump and do those things without losing their board from underneath them. So really, when we're talking about sort of how that happens, how they're able to do that, then this is a great way for them to understand those contact forces that are in play at that point in time to make that happen. If you've got kids and we finally get snow, whenever you're watching this, you might say, you know, if they're snowboarders and if they do any kind of jumping and anything that's in the chutes, again, how are they able to go up there, make a turn, and still have that board underneath them? So what are the forces that are in play there? So just making it real for the students as they're going through. But when we talk about sort of starting off with non-contact forces, I want to say to you that everything I'm going to suggest to you is not going to be presented as contact forces are, friction is, gravity is. The way this has been designed now is everything that we show them, we're going to unpack, and we want feedback from them. What did we learn? Are they getting it? Are they making the connections and the relationships between it? So when we ask them to explain or define or whatever it is I want them to do at that point, it's not because we gave it to them on the board. If you prefer to do it the other way around, then again, just be aware of that so that you're not maybe following it in the kind of the order that we have it up here right now. So when we talk about invisible forces, you might say something like, you know, things move and yet we didn't even touch them. How's that possible? So how can that be? So we have some forces that make that kind of thing happen. We have magnetic forces, we have gravitational forces, and then we have electrostatic forces. Now, they don't unpack this in grade 4, but really it's worth talking about because most children are familiar with taking a balloon and rubbing it on their hair, and the static comes out, or it's stuck to their head, or it sticks to the wall, and creating that static electricity. So it's a mention, but it's not a study part of this particular unit that you're going to be unpacking with the students. We're going to focus on these two. And we're going to start with the gravitational one. So when we talk about coming home, I throw my backpack on top of the table. The table is in contact with my backpack. Backpack isn't moving. It's held in place by both its mass and the gravitational force. I can see that it touches the table. I can see the table and I can see the backpack. But those are the applied forces that they unpacked in grade 3. There's that imaginary force that's pulling down on the backpack, holding it in place, called gravity. And in this case, that's our non-contact. So that's where we want to kind of unpack things now from students' perspective. So then the question is, what exactly, if I can't see it, what exactly is gravity? And we might ask them that, and just to see what they come up with, right? That they know that they don't see it, but they know it's there. Well, what is it? If you know it's there, then really what is it that you're talking about? So in this particular case, defining gravity, this is a short little video clip, but it does go through lots of examples with the students. And what I'd like them to do is watch this without me telling them anything about it. And we're certainly not going to get into 9.8. We're not getting into the value of it, but we want them to understand how gravity works. So once they've watched this, we just have a quick assignment for them. Describe how gravity is non-contact. In other words, where's that word non-contact keep coming up? Why are we saying that? And then can you come up with 2 examples that were different than what was in the video? And so you might play it again, right? They might say, I didn't pay attention to those. So maybe I go back and I play it again and see what they come up with. And see if their examples are good examples of the non-contact, because that's really where we want to go. Okay, Ted, do you want to talk to this one?
Sure, and Chris just began her discussion on things like gravity and contact, non-contact. And if we think back to that assessment that I gave at the start, that's where we start talking a little bit. And I'm going to move into magnets shortly again. But at the surface level, we're going to want to make sure, as you'll see some of the activities that Chris is going to share with you shortly as well, there's some of the deeper learning activities that take kids and have them apply their understanding and of the concepts and the understanding in general using certain skills. And some of the skills may be divergent thinking. For example, one of the things you'll see later is that there's going to be a design thing happening where kids design something and create something. Well, if we want them to be creative about it, we need to look at those creative thinking skills. And that's introduced at the scientific methods, computer science organizing idea in grade 3. And it's not really touched on anywhere else. But when we think about it, when we talk about design process, we think about all those things we create, construct, there's always that creative thinking component. And so, Chris, you could just do a quick click on that link if you don't mind. And there's some things that may help you with using every day, for that matter, some creative thinking process, like making a purposeful and intentional plan to include creative and divergent thinking. We know brainstorming is one of those common things that we do, but we need to have kids understand what brainstorming it is, what the rules are, and so on. And this slide deck helps with that. Sometimes when we're designing things, you'll see we can go on to Scamper part, if you don't mind, Chris. I think everybody's pretty familiar with brainstorming and what the rules are, but with Scamper, we go down a couple slides to Scamper. It's really an acronym for something. And what it is the substitute for when you're creating something or changing something or designing something, you look at it and say, well, what can we substitute this for this? It may be substituting materials. It may be combining materials or ideas together. Maybe taking an idea, adapting or modifying with the M. Or maybe you've got something and say, well, it's built, clothespin is meant to hang up clothes, but maybe it's got another use that could be helped in the design of something. What can you eliminate to make better? Can you reverse or rearrange parts of the ideas? And so Scamper is something that can be used along the way to help kids become more creative with their ideas. But again, it does have to be done at a surface level with constant iterations, constant practice at various times for students to become, I guess, more independent in using some of these creative thinking techniques. So that's one thing that's available to you there from that slide deck, or from that slide. We can head back, Chris, to the main slide deck. Grade 4 computer science introduces the design process for grade 4 students. And again, it's something that's not only stuck and lives in computer science. And if you could just open up the design process information sheet, Chris, yeah. Design process in the computer science portion of grade 4 is really about understanding the problem. Then you form ideas, or you start generating possible solutions, and then you narrow it down to one solution. You plan for it, then you create it and make it, and then you troubleshoot, you analyze it. Is there going to be anything wrong with it? Was it good? Then we test it. And if there's something wrong, we go back to analyzing, saying what was wrong. We do the troubleshooting and so on. So those last 3 steps are kind of circular motion to get it right. But you can see how the design process is not just good for coding, and which is really where it's introduced at in terms of grade 4, or that computer thinking. Can it be used when you're creating a project or designing something? And Chris will share an example of a design project shortly. But these are all things that you'd maybe want to teach at the surface level. And that one last thing was the investigation. That's where you're going to see the steps of the investigation. Of course, I've got my links all bad. Sorry, that's okay. They will be working here when you get the slide deck. What it does is it shows the steps in. We're using grade 2 steps. These steps are not in grade 3, 4, 5, or 6. Yet when we investigate, these are the same procedures that we use. And so you'll see them there. This activity helps you to introduce the steps to the students. There's an activity to introduce what an investigation really is, why do we investigate, and so on. And we'll help you get through the steps. If you could scroll down, Chris, you'll see, for example, there are activities if you've never had students make predictions before, or make observations or conclusions and so on. They'll be there. I see the conclusions is not linked in there, but analysis, conclusion, prediction, they'll all be in there for introductory activities at the surface level once again. And that's why I have this slide at the surface level, because at the end of the day, you want to bring them all together and practice all those steps in some kind of a mini investigation.
So if we look at some of the things that we could have them do at this point, we might want to talk about gravity. And when we think about a lot of times, if you think about your children, if you were to say, I have an egg and I have a basketball and I drop both of them, what's going to happen? Are they going to hit the ground at the same time? Yes or no? And they're going to say no, because the ball is much bigger. And so again, it's having that conversation and not telling me what's actually going to happen and what might influence whether or not it would or would not. So again, how does gravity get affected by the mass of an object? So the greater the mass, the object, the greater the force of gravity. So, but that doesn't change that I'm going to, unless I have other resistant forces involved here, it doesn't change the fact that I'm going to hit the ground at the same time. So there's a couple of really good examples in here, but this Science Trek does a wonderful job of just unpacking that notion, right? Just small baby steps, because we're really trying to get them to start unpacking this on their own and coming back and always explaining to you what they know, what they've seen, what they've learned, refining their thinking, go back, refine it some more. So each time we give them a new bit of information, we're hoping that that's just going to add more to their understanding. And so really, when they talk about some of these fun facts, we could read through that. And the fun fact that's on the right-hand side really just points out to them that when something falls to the earth, they think it's falling to the ground. But really what it's falling to is the center of the earth, right? Where the core and the strongest point of the magnet, that's where their fault. That's why it's getting pulled down, is it's trying to get to the center. So if we could bore a hole that goes right down to the center of the earth, that's where it would stop. It wouldn't go through the other side. It would stop right there. And that's another one. They often think, well, if you could imaginarily put a tunnel from one end to the other and you just dropped, what would happen, right? So having that conversation with the students is a really important thing for them to do. And then if they're understanding the gravity as we're going along, again, I'm not filling in a whole bunch of definitions on the board here with them. I'm unpacking with them each step of information that I give them. And remember that every video that you have, regardless if they all say, what is gravity, always presents something just a little bit differently. So sometimes the child who didn't get it the first time round is going to pick up on a nuance that they didn't hear the first time round. So it's always good to have a little bit of a repeat. So if I did a video that was explaining something on a Monday, I would probably personally start with it on a Tuesday, but not the same one, right? I don't want them to hear the same thing. I want them to hear the same thing, but from a different perspective or a different presentation. And in the end, we want them to maybe answer the question, explain how gravity affects the same person's weight on Earth and on the moon. Why is it that this same man who's standing on the moon and on Earth isn't weighing the same thing? Again, we unpack that even more in space when we get to that, and we talk about weightlessness and all of those things. But this is a really good place for us to have that conversation about the effects of gravity. And so we have that conversation again, it's pointing to the center, right? So then hopefully they have that conversation, or part of their explanation includes that. So that's kind of our unpacking of gravity, which also still will influence some of the other things that are going to happen even with our magnets. But let's just unpack magnets now as a non-contact force. And it can be a contact force, but it can also be a very powerful non-contact force, and that's what we want to see. So the question is up front, okay, how can I make a model car move with only magnets? So there's where I'm going to ask them to come together at some point, and I want them to actually design. So when Ted was saying that there's a design question, that's their design question. We're going to unpack, how do I answer that question? How do I design a vehicle or a whatever to move where I'm not allowed to have anything other than magnets to make it move? What would that look like? And there would be efficiencies in that, and then there would be inefficiencies in that we would be looking for. But before I do that, I need to know something. I need to know, first of all, how does a magnet even work? So I'm not assuming that they know what a magnet is, even though I might say a magnet and they've held a magnet and they probably played with a magnet, but they probably haven't thought of it in terms of science. So what do they know about a magnet? What do they know about what it does, how it works? So giving them 2 bar magnets, let's say per pair of students, they could be working as a team, and ask them to see what happens when they lay them on the table. Just lay them down. I'm not telling them about poles. I'm not telling them anything. I just want to know, can they move the 2 of them together? And some of them might start it off, so yeah, they click together, they attract right away because they put north and south together. Whereas the other group might have the exact opposite. They try and push them together and they keep pushing each other away. And then we ask them, you know, what happens if you turned one of your magnets 180 degrees? So flip it around so that they're using the other end. And what happens now? So before it wouldn't touch, now it does. Now they're attracted. So there's some language that's going to come in here, attractions, repelling, right? Those are the pieces. Again, I'm not unpacking that for them. I'm putting it on the board right away. I want them to describe for me what happened. And if they know that language, that's even better. If they don't, we're going to unpack it as we go. Have the students find 2 items that their magnet will stick to or pull towards, or have that pull, and 2 that won't. And again, you have to caution them to stay away from any of the electronic stuff, right? Because magnets will destroy that kind of thing. So keep them away from the phones and computers and monitors and that type of thing. But what do they have around the classroom? Can they find something outside, you know, playground equipment, garbage cans, with whatever, metal seat, or the metal bars on seats that might be out in the park? So what is it that they can find that their magnets will stick to? And can they describe it? And then can they give a reason why they think that's happening? What do we know about magnets to know that that's going to happen? And again, I'm just going into an investigation here. Wow, you guys are doing great. You've learned a lot. You've told me a lot about magnets. In this investigation, once they've gone through that process that Ted was showing you, what we ask them to do here is really to identify what they think will happen with different substances. So they're going to make some predictions, and they may know all those. And you don't have to use the ones that are listed here. You could use any ones that you want, or add to this list or whatever, or have different stations set up. So in any case, what they're going to do is we've probably unpacked some of these words already. Maybe some of them you haven't, and that's okay. Tools, the materials that they're going to need. So they need their magnets. They need some objects that they're going to test. And then whatever objects you're going to give them, we'd ask them to sort in a prediction. Which ones do they predict will be attracted to the magnet? Which ones are going to stick to the magnet? And which ones just aren't going to do anything, right? And then they test them out and then put a check mark if they were correct, their prediction was correct or not, okay? So it just gives them an opportunity, and hopefully whatever other terminology we haven't unpacked, we're starting to get to that. We should be, by the end of this investigation, be able to kind of put all those pieces together. So explain your results. Why do you think the outcomes resulted the way they did? So they might say because some had metal in them. And hopefully they found some things that had metal, that were metal, but the magnet didn't work, because those are important for them to see as well. And if you have some of those available, like some copper wire, throw those in, so that they don't think that anything that's metal automatically is going to work on a magnet, right? That's a good thing for them to learn. For the items that were attracted to the magnet, try placing a piece of paper between them. What would happen? You know, what would they predict? Would they put paper in between? Will it still stick, or won't it? Right? Is there something else that they can try after the paper? What happens if they put their shirt sleeve in between? What happens if they put an eraser in between? Like, have them try different things out that's available, that you've either made available or that they can find in the classroom, and which ones still allow that attraction to happen and which ones don't. So can you find other materials, and then can you find material medium that does not allow? So we want them to just explore so that they're getting a really good understanding of what these magnets can do. Because really, remember what I've asked them to do, and that is, I want you to design a vehicle that can be moved with a magnet, okay? Not any powered little battery or anything like that. So again, there are a number of different videos that are available. And again, I would show these to the students. These ones will really talk about the poles and talk about the magnetic fields that come to play. And that goes very much to the summative that Ted was showing you about the compass, right? If they understand how those magnetic fields, these waves, why are these waves from the iron filings looking the way they are, they'll have a better sense of what that compass is going to do and why it's going to do what it is. So again, these are two really important ones. This one, there's a number of different days. It's only day 2 that you really want to look at. You don't need to look at them all. Types of magnets. Magnetite's another. It's a source in the ground. And there are places on Earth where that's a prevalent ore that you find in the ground. And it's a magnet. It attracts magnets. It has lots of iron in it. And so it's going to attract magnets. So students need to know that it's not always something that we've created, that it obviously is something that could be a natural product of the Earth or found in Earth. What are some other ones? I could make some temporary magnets. How do I make a temporary magnet? And I would typically ask my students, have you ever gone to a restaurant where you picked up your cutlery, and as you picked up the fork, the knife came with it, and it wasn't very strong, but it was enough for you to lift it up and take it? How did that happen? Like, how did that all of a sudden become a magnet? So then in this activity here, how can you make something magnetized? So that's one of the things that is an activity that comes up later as well. So can they make a temporary magnet? That one's not going to last forever. Okay. And then does it matter what happens to my magnet? This is another one. What if I took this magnet and cut it in half? If you gave me bar magnets, if there was a way that we could break it in half, and if you had some that you could do one example, what happens when you break it in half? They'll say, well, it probably isn't going to work anymore because the north and south aren't together anymore. Okay, so try it out. Let's find out. Is that true or not true? Right? So again, it's an exploration of determining what happens to that magnetic field. And in actual fact, when you break them in half, what you've got is 2 magnets, right? It automatically will generate the pole that it needs. So Earth is a magnet. It too has a core, a magnetic core. So it's like one super big magnet, really. It has a north pole and a south pole, and then it has those magnetic fields that go around. So then the question would be, if I'm now starting to understand all those examples that you've been giving me, I should be able to answer this question for you. How can a magnetic forces of the Earth, how can we use that to navigate? Goes back to the compass question. Why does a compass work? Why do we care about a compass? What does a compass do, and how does that help me if I get lost out in the woods? So then how do I make my model car? And it doesn't have to be a car. It could be a vehicle. It could be anything that moves, right? So they're going to need some products. They're going to need some materials that they can use, but we want them to design it. They actually want them to build it. We want them to try it. They want them to predict that it's going to work. And then I even threw in a little bit of grade 3 into this is, could your vehicle actually be able to go up an inclined plane? Would it be able to go up a slope? Would it be able to go down? Would you be able to hold it back? Like just giving them something else to add into it rather than once I've got it moving on a flat surface and I can explain to you why that's happening. Can I change the speed of it? How do I make it go faster? If I wanted it to go faster, do I just add more magnets? What do I do? Right? So this is a great little activity for design, but now they really have to think about what it is they're going to do. And you could use exactly the same template that they had at the beginning where they're doing their investigation. You could use that same template and adapt it for this and have them do their predictions and step what they're going to do for their design and so on. Anything to add to that one, Ted? Okay. We might also look at, can a nail be magnetized? If they've learned how to magnetize a pin, for example, can you do the same thing with a nail? So again, do an investigation, show the data. And again, these are not everything that you would have to do, right? These are some suggestions of things that they can do. If they're farm students, and if they're not farm students, a great one for them to research. Why do sometimes farmers give cattle magnets in their food? Why do they do that? They do. So why did they do that? Why did they make them swallow a magnet? Good research question for them. If you were to give me the following supplies, how would you build a compass? So if they were asked to build their own compass, what would they do to do that? Comparing and contact and non-contact forces. This is just another sort of grade 3, grade 4 version of how do I show you that I know the difference between the two. So a bit of a description there, but we also are looking for an example, something that's different than what we've seen before. Okay, and there's a link up here to this sheet and to a review of what a contact and what a non-contact picture might look like. So if they need a little bit of prompting, a little bit of help. So this is just an activity that they could use. This is another one. Is this possible? Is it possible for me to hold up a magnet and have a human body get pulled towards it? Why not? Why or why not? Because I guess it could be a why too. Depends on what that person has on. Okay, what about this one? I have this ball sitting on my desk. Is it possible for me to make it magnetized so that it would hold my paper clips? If so, how would you do that? What about this? Is this really happening? When I have a magnet like this, am I really seeing these iron filings? Is that really what they're doing? By now, they should be able to answer that question, no problem. But I'm not saying they would do all 3 of these. Maybe that's what you use as your summative. Whatever you feel works best based on the examples that you've given the students so far. This is a very cool one. It's a magnetic monster. It's really just goo, but it grows over top of anything that's metal, and it's very cool to watch. It really is an interesting little video. But then the question would be, why is it doing what it's doing? So again, it's looking at magnetic forces, and that's what pulls the goo. Literally looks like it's alive, and it encompasses it. So it's a great one to do as a class, maybe just as a fun activity, but it's a great one that ties their understanding of magnetism together. Okay, anything to add to that, Ted, before we go to Ange's stuff? Okay, so then Ange Deering, remember she does computing science videos for you. She also provides you with a slide deck that has activities in it that are specifically geared to grade 4, in this case, energy. So she tries to tailor it just to what your outcome was asking for your students. And that way, just to make that computing science just come alive a little bit more, and to make it, if it's not an area of comfort for you, then you've got some ideas that you can draw from. You don't have to use her ideas. You've got some already from Ted's summative at the beginning that we could use, but there's great linkages in her video. So I encourage you to watch those. Some resources that I've just added in here. So if you need some more things on gravity, you've got some extra videos in here.
What goes up?
If I'm looking at magnetism, so this is one where they actually show them how to build the car. So you don't want to show that one to them off chance if you're going to use that end one as a design. It's a 26-minute video so that you're aware of it as well. And it will talk about repulsion, and it also talks about attraction. So it uses that terminology just so that you're aware of it. This is another one of those resources that I was mentioning to you before, where we have the rights to download both the student resource and the teacher guide. The teacher guides are generally about 200 pages, so you could definitely just look at them online. But you can download them. They're all linked in here. And basically what it's showing you is the non-contact courses. So you have a student resource, which is literally like a little student mini book, which has pictures and things like that of talking about magnetism and gravity. But in this particular unit, the way they designed it, they also have an activities like an investigations booklet. And again, you would never do all of them in there, but maybe there's a different one in there that you're looking for, just another example. Have a look, grab one from there. Sheets are already done. And the student work pages are the recording, the places they would record their results of the investigation that you've selected. So it's a paired booklet. They're a great little resource, well done. So it might be something you want to have a look at. So again, magnets appeal or attract and repel. This is very surface level. So if you want something just, my kids are still struggling from the very beginning on, then you would take these two K5 learning ones. They are just worksheets, literally, where in some cases they're a matching to say this would attract or repel. And other ones, it's a fill in the blank, but these are surface level. There's no deep thinking happening here. This is just a quick, they got it or they don't. Okay, looking for some experiments on magnets. These are a number of different ones, so you can choose again if you want something different as an investigation. And electromagnets, we don't do them in this course, but you might have some high flyer students that are really keen on this or already know something about it. How do you make one that has a bit of a cell connected to it, and how does that change things, right? How can I magnetize something using that? Do heavier objects actually fall faster than lighter objects, right? That's a great question to ask them. And you could even use that as a summative at the end if that's what you want. If you're not feeling that they're ready for that, then I could just use that and do the video that goes along with it. What did you learn? How would you answer my question now that you've watched it?
A question that is...
Okay, and a number of books that we have found now that work exceptionally well in this particular unit and for grade 3. Balanced and Unbalanced Forces. Electromagnetism is a couple of slides that I took from that booklet itself. We have Forces of Motion. This is a cartoon type of book, kind of a graphic organized book, but it is very scientific. There's nothing fake about this. So it's just done with a character. Kids love it from that perspective. And they have one for magnetism and they have one for gravity. So those are the Max Axiom books. Those Max Axiom books also have a teacher's guide to it, which takes you through investigations. They have a little quiz that goes along with each one if you're looking for some questions, but those are all part and parcel of that same one. Electricity and Magnetism, this is a great booklet as well that you might want to have a look at and fits exceptionally well with grade 4, not with anybody else's grade. Forces in Motion, you had a look at this already and you've seen a lot of the things that were in here. Some of the slides and pictures that we used came from this book as well as this one. This is one, now some of you may be familiar with On the Mark Press. They had books out already for the old curriculums that we had, and they were tailored and written specifically by grade. So if you wanted, a grade 1 teacher could go out and buy the On the Mark book here in Alberta, and it had sort of beginning to end everything that we did in that grade. So they've created some now for the new curriculum as well. So you might want to check some of those out if you're looking for that kind of resource. But we're not looking for worksheets, right? And they're not, I'm not saying that they are worksheets, but that's not our focus, right? We really want the kids to be engaged and to really unpack these. These are some that we had from grade 3 that may or may not be helpful depending on where your students are going to start. Gravity, this is a grade 3 one, but it's a great little starting book if I'm just trying to get my head around some of the terminology. And that is all that we have to share with you at this moment in time. Seems kind of odd that we're showing you a Merry Christmas ball, but we won't see you until after Christmas when we do space. And so we do wish you, who's December coming up, a great holiday and a good relaxation. We'll take some questions if you have any. At the end here, I'll stop the video as well. Ted, is there anything that you wanted to add into any of those slides or anything that we're doing?
No, I think that's it, Chris. I think this is a really good, as you've probably seen from all the examples that Chris has shared, this is a really good organizing idea to get kids really doing a lot of hands-on stuff and investigating and predicting and asking questions and exploring. So, and the materials required to do this are really, they're inexpensive. They're around the classrooms. They're around all the environments we're in. So this could be a fun one, I think.
And then also just a reminder too, that when we do the space unit, after space, shortly thereafter, we also had set aside 2 days, 2 full days. They're not together back to back, they're separated. I believe the first one's in February and the second one is in April. And those were designing assessments. So we thought we would look at what could some assessments for grade 4 look like. There's another one for grade 5 and another one for grade 6. So if that's something that you would be interested in, you might want to check out the ERLC or CARC site and register for those. There's no charge for those, but if you are interested in developing maybe ahead of time before everything comes out, a little bit of assessment with that, then feel free to join us in that as well. I'll just stop the recording here. I don't want people to feel uncomfortable.